Three identical, very dense masses of 6,800 kilogram each are placed on the x-axis. One mass is at x is equal to minus 140 centimeters. One is at the origin, and the one is at x2 is equal to 410 centimeters. What is the magnitude of the net gravitational force on the mass at the origin due to the other two masses? Take the gravitational constant to be g is equal to 6.67 times 10 to the power of negative 11 Newton meter square per kilogram square. Express your answer in newtons to three significant figures. What is the direction of the net gravitational force on the mass at the origin due to the other two masses? This numerical problem is based on gravitation. These are the three masses. One is at the origin and another one is at 410 centimeters, positive x-axis. That means towards this. So 410 centimeters means 4.1 meters. The other one is 140 centimeters, negative x-axis. Okay. So 140 centimeters means 1.4 meters. And then mass are all the three are of the same mass. So that means 6,800 kilograms. Now FG1, that means force of attraction between M1 and M0 is equal to G M0 M1 by R squared. Plug in the values, you will get the number as 1.57 times 10 to the power of negative 3 newtons. Next, FG2. For FG, that means the force of attraction between the MO and M2. Here also you have to plug in the values in the G M0 M2 by R square. Here R square is equal to 4.1 meters. Okay. And you get the value 1.83 times 10 to the power of negative 4 newtons. Observe the forces. Okay. The one which is closer has the more force compared to the other one. Okay. This is at a distance of 4 meters, 4.1 meters. So it has a lesser attraction, a force of attraction. Whereas this one is a bit closer to the mass at the center or the origin. It has the more force of attraction. Now we have to find out the net force. To find out the net force, you have to subtract because one is positive, another one is negative. Actually, we are adding one is positive, another one is negative. Therefore, the net force is equal to 1.39 times 10 to the power of negative 3 newtons. Okay, so this is which direction? Towards the negative direction, no? Because this is the negative direction. We can write like this. This is a negative. Okay, this as a positive. Suppose if we write like this, it will become the negative. Okay, negative sign indicates negative x direction. Understood. Actually, here we get the absolute values because the negative sign is when we square it, it becomes the positive. We are getting the absolute values. But in negative direction, I am putting the negative sign and then positive direction as the positive sign. And then we are getting the negative value. Okay, but when we take the absolute value will be 1.39 times 10 to the power of negative 3 newtons. But when the negative sign indicates the negative direction, negative x direction, or towards x1 or towards the m1. Here, I write instead of x1, I write m1 towards m1 or negative x direction. Okay. So this is the answer for this question. Hope this helps. Thank you. Bye-bye.